All right, so title, wherever you are going to write this, we are doing complete the square. So we are doing complete the square day 1. And just so you guys are aware, when we start this is really just rooting again. So we're going to do a lot of rooting today. We're actually going to start with just a review of what rooting is. Because out of our 5 total styles, we can solve by graphing, factoring, rooting. Completing the square is really rooting again, and then we have a formula we'll go through at the end. So rooting. We know we can solve something by rooting if we have how many spots with variables? 1 spot with a variable. So we're just going to review rooting. I know I can solve this by rooting because we have 1 spot with 1 variable, so we just have an x squared. Rooting just means, really, what are we getting by itself? The x. What do I have to move over first to solve this equation? The 8. How do you move a minus 8? You cannot undo the squared until it is by itself, so what needs to be undone after that? The 25. How do you undo that 25 since it's touching the x? Divided. Now, does 9 evenly get divided by 25? No. So if it does not evenly divide, just leave it as a fraction. Once the x squared is by itself, now you can undo it. How do you undo an x squared? Square root. The reason I say to leave this as a fraction is when you take the square root of a fraction, do you do it to top, bottom, or both parts? Both parts. So it's taking the square root of a fraction is super easy. What's the square root of 9? What's the square root of 25? You just took a square root, so what needs to go in front of it? Plus and minus. So fractions are way easier than having to copy down all those decimals and use your calculator. Big picture. Does this hit the x-axis? Yes, twice. 3/5 is just a decimal, so it's just hitting at a decimal. Another one with rooting. Again, I know I can solve this by rooting because we have 1 spot, 1 variable. What needs to move over first? The -3. So I'm going to add my 3 over. What has to be undone after that? The 5. Does 21 evenly get divided by 5? No. So just leave it as a fraction. Once you have x squared by itself, how do you undo x squared? Square root. Now these two problems look pretty similar, but now they're going to be very different. How is this fraction 21/5 different than 9/25? They're not perfect squares. So what do you think I'm going to tell you guys? If they're not perfect squares, what do you think we're going to do with them? Just leave it. So our answer is just going to be the square root of 21 divided by 5. You just took a square root, so what needs to go in front of this? Plus minus. Is this graph going to hit the x-axis? Yes, it's just at a weird decimal. You can punch this into your calculator. It would just be at a decimal. Just leave it as exact. Another one with rooting. Again, I know I can solve this by rooting because we have 1 spot with 1 variable. Rooting just means algebraically get x by itself. What do we have to do first? Minus the 18. Is our x by itself, or is our x squared by itself? No. So how would you move that 2 over? Divide it. So you cannot undo the x squared until it is isolated. Once the x squared is by itself, then you can undo it. When I take my square root, 9 is actually a really good number. What's the square root of 9? 3. What's the square root of -9? 3i. So the 3 comes from the 9. The negative, when a negative comes out of a square root, it turns into an I. What kind of number is that called? Imaginary number. You still took a square root, so what still needs to be in front of this? Plus minus. Big picture, is this graph ever going to hit the x-axis? No. This is one style of rooting, where you just have an x squared and you just algebraically get x by itself. Do you guys have any questions on this style? So the other type of equation you can solve with rooting are where you have the parenthesis ones. So it looks very different, but do you see how there's still just one spot, one variable? So with that one spot, one variable, we can still solve this by rooting. Rooting just means algebraically get x by itself. What would have to move over first? The 1. How do you undo a plus 1? You minus it. And then can I move that 4 here? No, you cannot get inside parentheses until the outside is gone. So how do I undo that exponent of 2? Square root. So when I take my square root, those will cancel, but I still have that x minus 4. And then on the other side, what's the square root of 25? 5. You just took a square root though, so what needs to go in front of that 5? Plus minus. So on the quiz you guys took, the plus minus does not appear at the end. It appears whenever you take that square root. So just make sure whenever that square root happens, that's where your plus minus is. This one, we still don't have x by itself. So how do you move that minus 4? You plus 4. Now when I add this 4 over, I don't want to just do 4 plus 5 is 9, because remember that 5 is technically how many numbers? 2. So it's a 4 with the plus or minus 5. So whenever you have to do one more step to get x by itself, just let it be in front. Once you have it written this way, then you can look at it and be like, do you see how 4 and 5 are both just regular numbers? Put them together. What's 4 plus 5? 9. How do I get my other answer? Yeah, 4 minus 5 is negative 1. So we have two answers, but notice how they're not plus or minus the same thing, because that plus minus happens earlier, because whenever you take the square root, that's where it appears. Does this graph hit the x-axis? Yes. Let's do another one with rooting. What am I doing? So 2 quantity x plus 2 squared equals negative 18. So rooting wise, I know I can solve this by rooting because there's one spot, one variable. So algebraically, what do we have to move over first? The 2 in front. So that 2 in front, it can't be multiplied in because of the squared. It's touching the parentheses, so that means it's a multiplier. How do you undo a multiplier? Divide. So I'm going to divide. Right here, are we going to take the square root, or are we going to minus 2? Square root. So once the thing squared is by itself, that's where you undo it. Those cancel. And then what's the square root of 9? 3. What's the square root of negative 9? 3i. So when the negative comes out, it turns into an I. You just took a square root, so what needs to go in front of that? Plus and minus. So right here we know, is this graph going to hit the x-axis? No. That's all the I answer means for us right now, is these graphs do not hit the x-axis. Last step to get x by itself, how do I undo a plus 2? You minus it. Do you think a 2 and an I can be combined together to make a 1? No. So it's a negative 2 plus or minus 3i. We learn more about I later. I kind of acts like a variable. And what I mean by that is if I had like 4 plus 9x, can a number and an x be combined together? No. So 2 or negative 2 is considered a real number. That 3 is an imaginary. So numbers can't be combined together with adding and subtracting unless they're the same type. So that's why I just leave them separate. The one we did right before it, these were both just normal numbers. That's why you can actually put them together. Numbers and I's aren't able to do that. Okay, last review question we're going to do. Negative 4, x minus 3 squared minus 11 equals negative 59. So again, this is just rooting. We know it's rooting because we have one spot, one variable. Rooting is any time you can just algebraically get that one variable by itself. What would our first step be to get this one by itself? Add the 11. So what is negative 59 plus 11? Well, negative 48. What's the next thing we have to do? Divide the negative 4. So you then get rid of that. What's negative 48 divided by negative 4? 12. Once you have the thing that is squared by itself, how are you going to undo it? Square root. When I take my square root, the left side is good because they're just going to cancel. The right side though, that square root of 12. Is 12 a perfect square? No, so we want to break it down. What perfect square divides a 12? 4. It's really 4 times 3. The reason I break it down that way is what is the square root of 4? 2. What is still stuck on the inside? And you just took a square root, so what needs to go in front of that whole thing? Plus minus. Anything that you take out of a radical should be placed in front, even if it's an I. What's our last step to getting x by itself? Adding the 3. Now, do you think the 3 is going to be able to go with that 2 to make a 5? No. Regular numbers and radical numbers, regular numbers and I numbers cannot be put together, so you just leave them in that line. Big picture, is this graph going to hit the x-axis? Yes, it's just at a weird decimal. There's no I. The only ones that don't hit are the I answers. Do you guys have any questions on that style? Okay, we are going to kind of shift gears a little bit and then it'll eventually fill in. We are actually going to do a quick little factoring review. Factoring. Let's factor x squared plus 8x plus 16. So factoring wise, is there a GCF here? No. So if I were to factor this, factoring is when you put it in its parentheses. Where do I get an x squared from? X and x. If I look at my signs, I have a plus sign at the end. So do I have same signs or opposite signs? Same. Look to the middle. What are they both going to be? Positive. How do I get a 16 with an 8? 4 and 4. If you're ever not sure of your factoring, what can you do to see if you got it right? Foil it back out. So 4x, that's going to give me my 8. Now, do you see how both of our parentheses are the same thing? So instead of writing x plus 4 times x plus 4, I could just write it as x plus 4 quantity. How many of those x plus 4s do I have? 2. So factoring wise, putting it back into its parentheses. One more review of factoring. 4x squared plus 20x plus 25. Is there a GCF here? No, because 25 can't be divided by 4. So when you do your two parentheses, what options do we have to get that 4x squared? It's either 2 and 2 or 4 and 1. What's our better option to try, the 2 and the 2 or the 4 and 1? 2 and 2. If you have perfect squares, I would try those first, especially because if you look at your ending number, how do we get 25? 5 and 5. What do our signs have to be?
Plus.
Is this going to give us that 20 in the middle? Yes, because if I FOIL this, 2 times 5 is 10, 5 times 2 is another 10, 10 and 10 is 20. So if you have perfect squares, you should try those first. Now they're both 2x plus 5, so instead of writing the same parenthesis twice, we can just write 2x plus 5. How many of those do we have? 2. Now, this style of factoring, these are called perfect square trinomials. Perfect square trinomials just mean we're starting and ending with perfect squares, And the middle works out to use those perfect squares. So do you see how perfect square trinomials factor really nicely? They end up being the same thing, two of them. If you go back to the rooting examples we just did, this 2x plus 5 squared, this x plus 4 squared, doesn't that look kind of like these? Like, do you see how it's the same setup? So what we are going to do is when we go through completing the square, what completing the square really is we're forcing the rooting process. So when I say we are going to learn how to complete the square, what we're actually going to learn is how can I force this so I can solve it by rooting. Today we're just going to practice the setup of it. Tomorrow we'll actually finish the problem out. So today is kind of just part one. Tomorrow is we'll actually go through and finish it out. So completing the square, technically it is a new style to solve, but in reality it's just more rooting, except for we have to work a little bit harder at the beginning. And the reason we're going to do this is if we can get something squared, it's pretty systematic. Like when you solve by rooting, it ends up being pretty repetitive. So what our goal is we need to figure out how do we get a perfect square trinomial. And it's going to look kind of weird to begin with because we're not going to be given a full expression. Our goal is to figure out what number could I put there. So what our goal is we want to figure out what number goes at the end so that we can factor this as a perfect square trinomial. If you Google this, if you look up PhotoMath, ChatGPT, whatever, they're going to use a formula. I am not going to show you guys the formula because I think it's way more systematic, quicker, visual. If you use this method, you'll learn the formula on your own. But to begin with, we're going to focus on the word square. What is special about a square? Like, how is a square different than a rectangle? All the sides are the same. So when we complete the square, we're literally going to draw a square. And this is going to feel very familiar to like biology, physical science when you guys did genetics. We're going to use, essentially it's a Punnett square. So the thing about a square, the sides are even. So x squared, if I evenly split an x squared, it splits into an x and an x. And if we go back to like those genetic squares, if I just multiply these, what's x times x? X squared. So I still have my x squared. Now this negative 14, it's a square, so they have to be the same. How do we evenly split negative 14? 7 and 7, right? Do you guys agree 14 cut in half? Now since it's a negative 14, is it a positive 7 or a negative 7? Negative 7. So I'm just going to put negative 7, negative 7. And if I do my multiplication, like x times negative 7 is negative 7x. X times negative 7 is negative 7x. These two together, is that still negative 14? So like I haven't changed anything, I've just split it up. Now completing the square, this is the magic part. If I complete my square, what's negative 7 times negative 7? 7 times 7? 49. Which means if I put a 49 at the end, this should now be really nicely factorable because all I did was I completed my square. Squares are the same. If I factor this, x squared, that comes from an x and an x. Do we have same signs or opposite signs? Same signs. Look to the middle. What do they both have to be? How do we multiply to 49 add to 14? 7 and 7. And instead of writing x minus 7 twice, I could just write x minus 7. How many of them do I have? Squared. Now, here's why I love doing this square method where instead of the formula, if I look at my square, do you see how on this side I have x minus 7? Do you see how on that side I have x minus 7? How many of those x minus 7s do I have? 2. The square does the factoring for you. So the idea of completing the square means we are trying to figure out what number needs to go at the end so it can factor really nicely. So again, we are forcing this to be nicely factorable, because obviously there's lots of different ways we could get a 20 in the middle, but we want to figure out what way could we get a 20 in the middle where it's going to factor really nice. Completing the square is the way we are going to do it. And the key thing about a square is your sides are the same. So x squared, if you split an x squared, it's an x and an x. That middle number, you have to split it in half because a square has even sides. What's half of positive 20? Positive 10 or negative 10? Positive 10. So if you wanted to, you don't need to. X times x is x squared, x times 10, 10 times x. Like, you still have your 20 in the middle. The key part is, if you complete this square, what's 10 times 10? 100. So if I put 100 at the end of this expression, this is now going to be something that is very easily factorable. The way you find your factors is what's on the side of our square. What's on the side of our square? X plus 10. How many of those x plus 10s do we have? 2. And if you're not sure if that's right or not, like, you can factor this the normal way. X squared is x and x. Multiply to 100, add to 20, it's going to be a 10 and a 10. So completing the square is the process of taking that to that. Tomorrow we'll do more with it. We're going to do 2 more. Okay, next one. X squared plus 54x plus what number? So what number do we need to put at the end of this so we can factor it really, really nicely? Completing the square is the process of figuring out that last number. When you complete the square, you literally start with the square, and now you start evenly splitting everything. So how do we evenly split an x squared? X and x. Our next number is that 54. How do you evenly split a 54? Positive or negative? Positive 27, positive 27. And now what number is going to complete our square? What's 27 times 27? 729. Which means if I put 729 at the end of this expression, I can now factor this really easily. You don't even need to think about it. Look on the side of your square. What's on the side of your square? X plus 27. How many of those x plus 27s do we have? 2. So we are creating our own ending number so that I can take my expression and factor it really nicely. We're going to do one more. X squared minus 5x plus what number? So the idea of completing the square is we are forcing our equation to be nicely factorable. So we are figuring out what number needs to go there. Whenever you complete the square, you start by drawing a square. Squares are special. Squares have side lengths that are the same. So you just split everything in half. How do you split an x squared in half? X and x. What makes this one a little bit trickier than the other ones? Yeah, you can't split a 5. Fractions are going to be your best friend here. So when I split this, can negative 5 evenly be divided by 2? So as a fraction, just leave it as negative 5 over 2. If you do negative 2.5, technically you'll get the right answer, but you're going to make every step after it a little bit trickier. So if your middle number cannot be divided by 2, just leave it as that number divided by 2. The reason fractions are better is when I multiply these, if I have negative 5 halves times negative 5 halves, how do we multiply fractions? Straight across. What's negative 5 times a negative 5? What's 2 times 2? 4. So what number do we need to add on the end of this expression? 25 fourths. Because fractions, you just multiply the top, multiply the bottom. Now, even though these are really goofy numbers, your factoring is done for you. What do we have on the side of our square? What's inside our parentheses? How many of these x minus 5 halves do we have? 2. So the idea of completing the square, we are picking this number so that we can then factor it really nicely. Tomorrow we will actually kind of figure it out.